Hey everyone and welcome to this one shot video on ICSE grade 10 circles. Very interesting chapter, important as well. You can expect one question from this particular chapter. We are going to solve previous year questions and we are going to deal with a lot of problems. So I hope all of you are excited alongside me. Let us try to understand how many questions were asked from 2018 to 2024. So if you see, at least one question is asked every year, right? So here one question of 1 mark was asked. In 2020 you can see 2 questions were asked. In 2018 1 question was asked. But also there were 2 questions of 4 marker asked in 2018 and 2019. So you can also expect a long question from this particular year, because if you see for the last 2 years the question of 4 marks and 3 marks was not really asked. So we can expect a 3 marker or a 4 marker in this particular exam as well, right? Okay. So let us dive into the questions straight away. You can have a screenshot of this if you want for better clarity. So here is the first question. The first question says, quadrilateral PQRS is a cyclic quadrilateral. Now what is the meaning of a cyclic quadrilateral? A quadrilateral where all the 4 vertices lie on the circle. So quadrilateral PQRS is a cyclic quadrilateral. It is given that angle QPS is 73 degrees. It is given. Everything is there in the question if you see. Angle PQS is 55 degrees and PSR is 82 degrees. Now PSR means, understand, PSR, the entire angle is 82 degrees, right? We are supposed to calculate 3 angles here. Angle QRS, then angle RQS and angle PRQ. So let us focus on angle QRS. So QRS is here. Can I say this is very simple to find out angle QRS, because we know that whenever we have a cyclic quadrilateral, that is we have a circle and we have a quadrilateral inscribed in it, then the opposite angles are supplementary, right? What is the meaning of supplementary? Their total or sum is 180 degrees, correct? So if I focus on the first part, that is angle QRS, let's move on to the solution. So already it is given that PQRS is cyclic, right? PQRS is cyclic. So can I say therefore angle SPQ or QPS plus angle SRQ or QRS, same thing. Angle, I have QPS, right? QPS plus angle QRS, that is equal to 180 degrees. What is the reason behind this? Opposite angles are supplementary, right? We can write down opposite angles. Opposite angles are supplementary. You have to write down the complete reason, always remember. So QPS is already given 73 degrees. So can I say 73 plus angle QRS is equal to 180 degrees. So if I shift 73 degrees to the other side, I get angle QRS is equal to 180 minus 73. And how much is 180 minus 73? 180 minus 73 is 107, right? So 107 degrees. So we got the measure of the angle QRS, that is 107 degrees. I hope this question is clear to you. I mean the first part, this is 107 degrees. Okay, let's focus on the second part now. RQS. So let us focus, where is RQS? RQS. Now understand, to find out RQS, firstly we know this is how much? This is 107, correct? Now this entire angle is 82, but if I focus on triangle QPS, in triangle QPS, this is 73, this is 55. Can I find out this angle? That is angle QSP. So can I say the sum of the three angles here, that is SPQ plus SQP plus PSQ. Angle PSQ plus angle SQP plus angle SPQ. That is 180 degrees, because sum of all angles of a triangle is 180. Now out of which the two angles are given 73 and 55. So can I say angle PSQ plus we have SPQ and SQP. So you can write down 55 plus 73. That is equal to 180. So that becomes angle PSQ is equal to, so 5 plus 3 is 8, right? And 7 plus 5 is 12. So this becomes 180 minus 128, correct? So that gives you 180 minus 128 is 52 degrees. 52 degrees. I hope this part is clear to you. So this is 52 degrees, right? This particular angle. We have applied angle sum property of a triangle. We got the measure of this angle as 52 degrees. Now this entire angle is 82. Entire angle is 82, out of which this part is 52. So how much will be the remaining part? So can I say angle RSQ, angle RSQ is equal to 82 minus 52, that is equal to 30 degrees. Now once we get this angle, I'm talking about this angle. This is 30 degrees. Now can we apply angle sum property over here? This is 107, this is 30. Can I find out the remaining angle over here? Yes, I can do that. We can apply angle sum property in triangle QSR. So I can say in triangle QSR, again same thing, angle RSQ 30 degrees. See the orange part, 30 degrees plus the second angle is 107 plus the third angle is the required angle RQS, right? RQS. That is angle RQS is equal to 180. Now you can add this. So what is 107 plus 30? That is 137. So can I say 137 plus RQS is equal to 180. So if I shift 137 to the other side, I'll have to subtract 180 and 137. That gives me 43 degrees. So can I say angle RQS is 43 degrees, right? So I hope this part is clear to all of you. Now we are supposed to find out PRQ. So let us focus, where is PRQ? PRQ, now that is slightly different, understand. So PRQ, for that I need to join this, right? And we are supposed to find out this PRQ. Okay, now understand. To find out this PRQ, observe angle PSQ. See, there is a base, there is base PQ. Base is PQ. The angle goes like this. This is PRQ. With the same base, there is one more angle over here, that is angle PSQ. But if you remember, we have already calculated angle PSQ, and angle PSQ is how much? This was 52 degrees, correct? So can I say angle PRQ is equal to angle PSQ. Okay, so angle PRQ is equal to angle PSQ. This is what we got. So how much is angle PRQ now? Because PSQ is 52 degrees, we can say that angle PRQ is equal to 52 degrees, right? What is the reason that you will write down? Angles in same segment are equal, right? angle subtended by same segment, because if you see, this PQ is subtending these two angles, where on the circle, right? And both the points S and R are on the circle. In that case, they are always equal. Okay. So I hope you have got this question. We have solved all the three parts. Simple. Let us move further. Okay. Now this is a 3-mark question. This was asked in year 2018. Now let's try to understand the question. In the given figure, O is the center of the circle and OR is equal to OP. QR is equal to OP. Where is QR? QR is here. Where is OP? OP is here. Okay, they are equal. And angle ORP is 20 degrees. Okay, we are supposed to find out the value of X. Interesting question. Now firstly tell me, O is the center of the circle, right? So can I say that OP and OQ are equal? OP is equal to OQ because both of them are radii of same circle, right? OP is equal to OQ because they are radii of same circle, but OP is already equal to OR given. OP is already equal to OR, that is given. So can I say if OP is equal to OQ and OP is equal to OR from 1 and 2, can I say OQ is equal to OR? Right, from the above two statements. So OQ is equal to OR and I have a triangle OQR, right? I have a triangle OQR where these two sides are equal. So can I say this is an isosceles triangle? And we know that in an isosceles triangle, the base angles are equal. So can I say angle R is equal to angle O here? So this angle O is also going to be 20 degrees. So we can say that in triangle OQR, so we can say in triangle OQR, because the two sides are equal, we can say that angle ORQ and QOR, angle ORQ is equal to angle QOR, right? And that is equal to 20 degrees. Correct? So up to now what did we get? We got this angle. We got this angle as 20 degrees. Now if I apply angle sum property in this triangle, triangle OQR, can I find out the measure of this angle? Yes, I can do that because this angle plus this angle plus this angle is 180 degrees. So I can say that in triangle OQR, I hope you are able to identify the triangle as well. I am talking about the triangle OQR. So in triangle OQR, I can say that first angle is 20 degrees plus second angle is 20 degrees plus third angle is OQR. OQR, that is equal to 180. So 20 plus 20 is 40. So can I say 40 plus OQR is equal to 180? So you always write down the reason. What is the reason for this? Sum of all angles of the triangle is 180 degrees, or angle sum property of triangles, right? Okay. So can I say angle OQR will be equal to 180 minus 40, that is 140 degrees. So this angle over here, the orange part, is 140 degrees. Now can I say if this is 140, correct? If this is 140 and this is a linear pair angle, right? So can I find out Q? So Q will be what? The inner part. We have a straight line, right? And we have like this. So if this is 140, the inner part is going to be 40 because they are in linear pair. So to write down all the statements, although the calculation part is not much, it's very simple, but then we have to give the reason every time, right? So we can say that angle OQR plus angle OQP. Angle OQR plus angle OQP is equal to 180. Already this angle OQR is 40. So 40 plus angle OQP is equal to 180. So if I shift 40 to the other side, that's 140 to the other side. So that gets angle OQP is equal to 180 minus 140, that is 40 degrees. Now understand, still the question is not over because this angle is 40. Now can I say these two are equal? We already know. So it is an isosceles triangle. The triangle in the middle, if you see, is an isosceles triangle OPQ because they both are radii of the same circle. So if this is 40, can I say this is 40? Correct. So if this is 40, how much will be this? 40 plus 40 is 80. So can I say angle POQ? Angle POQ will be equal to 180, and then you will subtract both the angles 40, 40. I hope you are getting this. So that will give me 100 degrees. Which angle? Angle POQ. Just highlight separately. So this green part is 100 degrees, right? 100 degrees. Now understand, this angle is how much? We already calculated this is 20. This is how much? This is 100. Now can I calculate x? See, if you see the line like this, it is like this. Here I have 20, here I have 100. So this is question mark. So can I say TOP? Angle TOP, you must have got the answer by now, plus angle POQ plus angle QOR is equal to 180 degrees. So TOP is x. Can I say x plus POQ, which is 100 plus 20 is 180. So 100 plus 20 is how much? 120. So can I say x will be equal to 180 minus 120, that is 60 degrees. I've done it directly, but you can do the calculation. This is 120, 120 goes to the other side, and we got the measure of angle x as 60 degrees. So I hope you have understood this question. See, I'm going a bit slow because there are a lot of concepts used here. You can see isosceles triangle was used, radii of the same circle was used. Then you can also see straight line was there, angles in linear pair, because if you see this part, right, we got this as 140 and then we calculated the inner angle, right? So this was 140 and we calculated this as 40 degrees. So that was angles in linear pair, isn't it? So all of this, I hope you have understood how we have solved this part. Let's continue further. Okay. Now is a new question. This was a 4 marker. So again, I'll go a bit slow because ample of concepts are used here. So in the given figure, A, B, C, D, E is a pentagon, obviously because there are 5 sides, A, B, B, C, C, D, D, E, A. And then it is given that AC is the diameter. This is an important information for us. AC is the diameter. Okay. Side BC. BC is parallel to AE. This is BC. This is AE. They are parallel to each other. And then BAC is 50 degree, which is given in the question. We are supposed to find out 4 things here. 3 things we are supposed to find out, and the 4th one is proving angle ACB. So where is angle ACB? It is over here. Okay, let us focus only on the first part. Let's forget about the other parts. Let's focus on angle ACB. Now tell me one thing, if I have a circle and if I have a diameter and if I have a point on the circle, what will be this angle? Can I say it will be 90 degrees? Because we know that angle in a semicircle is a right angle. The lower part is a semicircle, right? So here we can say that, firstly, AC is diameter. We can say AC is diameter. Therefore, angle ABC will be equal to how much? Angle ABC will be equal to 90 degrees. What is the reason? The reason is angle in semicircle. Angle in a semicircle is a right angle. Okay, so we got this. So now if I take this triangle ABC, I know that this is 90 degrees. This is 90 degrees. Can I find out this? Angle sum property of triangle. Very simple. So can I say in triangle ABC, I can say angle ABC plus angle BAC plus angle ACB is equal to 180 degrees. This is because sum of all angles of the triangle is 180. Now we know the two angles 50 and 90. So I can write down 50, or first is 90, no problem. The order doesn't really matter. Plus 90 plus angle ACB is equal to 180. 50 plus 90 is how much? 140. So can I say 140 plus angle ACB is equal to 180 degrees. So angle ACB will be how much? 180 minus 140. So I can say angle ACB is equal to 180 minus 140. That is 40 degrees. This part is 40 degrees. Okay. Now we are supposed to find out the measure of angle EDC. EDC, that is over here. So this is what we are supposed to find out. Not only that, if you see, what all do we know? We know that this angle is 40. Correct? Okay. Now understand. So tell me one thing. If this angle is 40, there are two lines which are parallel to each other. AE. This is A. This is E. This is C. This is B. AE and CB are parallel. Correct? And we have a transversal. AC is the transversal. So can I say I am getting alternate interior angles? So can I say angle EAC and angle ACB, both of them will be equal? I can say that angle EAC, right, is equal to angle ACB. Why? Because what is the reason? They are alternate angles, or you can say alternate interior angles, right? Alternate interior angles are equal. Okay. So can I say that angle EAC, now angle EAC is equal to ACB, which is 40 degrees. Correct? EAC will be 40 degrees. So this is 40 degrees. Now understand. Now if I take a circle, the same circle, this only I have drawn here. I have AC, I have AE, then I have ED, and then I have this. So can I say I have a quadrilateral here? Because if you see the points, this is 1 point, this is 1 point, this is 1 point, this is 1 point. So this is A, here is E, here is D, and here is C. So can I say this is a quadrilateral and this is a cyclic quadrilateral? So I can say that AEDC is cyclic, right? Quadrilateral AEDC is cyclic. And since it is a cyclic quadrilateral, can I say that this angle plus this angle will be 180 degrees? Because opposite angles of a cyclic quadrilateral are supplementary. So that's it, we can do that. Now we can write down EAC plus EDC is 180. So we have EAC, angle EAC plus angle EDC, right, is equal to 180 degrees. What is the reason? The reason that you'll write down is opposite angles of a cyclic quadrilateral are supplementary. So EAC is how much? EAC is 40. Okay. So 40 degrees plus EDC is equal to 180 degrees. 40 goes to the other side. So can I say EDC is equal to 180 minus 40, that is 140 degrees, correct? So we have done the second part as well, and this is 140 degrees. I hope you are getting this. Now let us focus on BEC. BEC. So for that, can I say I need to join this BE, I need to join this EC. Let's have a fresh figure. So I need to join EB, I need to join EC, and I am supposed to find out BEC, that is this angle. Correct? Now tell me one thing. Understand, I have a base, there is a segment BC, and then I have one angle over here like this. I have second angle over here like this. Can I say both of them will be equal? Because the same segment is subtending two angles on the circle. Same segment is subtending two angles on the circle. So if this angle is 50, can I say this angle is also 50 degrees? That's it. We have done this concept previously in the previous question as well. So can I say angle BEC is equal to angle BEC is equal to angle BAC. Why? Because both of them are angles subtended by the same segment on the circle, which is BC. Okay. So therefore, can I say angle BEC is equal to 50 degrees? Why? Because already we know that BAC is 50 degrees. So if I go back, I got this as well, that is 50 degrees. Now I am supposed to prove the last part. What is the last part? The last part that we are supposed to prove is BE is also a diameter. Now when will BE be the diameter? Now understand, whenever I have a circle and suppose I have a segment, this is a segment, I am not calling it a diameter. And if I have this angle is 90 degrees, tell me one thing, if this angle is 90, can I say this will become the diameter? Yes, because when this is the diameter, this is 90 degrees. When this is 90 degrees, this will become the diameter. Now understand. If you see the previous slides, this is 40, this is 50, and this is 40, right? And let me join BE. Now understand, if I try to find out angle EAB, can I say angle EAB is nothing but angle EAC plus BAC. EAC plus BAC. But EAC is how much? EAC is 40 degrees. BAC is how much? BAC is 50 degrees. How much is 40 plus 50? 90 degrees. So can I say angle EAB is equal to 90 degrees? Now if EAB is 90 degrees, what will be EB? Can I say therefore EB is diameter? Because what is the reason? EB subtends, right? Subtends 90 degree on the circle. That is why it is a diameter. That's it. So we have proved this as well. Very easy, very simple, right? All the 4 parts for 4 marks. Perfect. In the figure given below, O is the center of the circle and AB is the diameter, AC is equal to BD and angle AOC is 72 degrees. We are supposed to find out 3 values here. First is the measure of angle ABC, then is the measure of angle BAD, and then is the measure of angle ABD. Okay, let's focus on angle ABC as of now. ABC. Now we have already studied that if we have a circle and if we have the center of the circle and if I extend it further, so definitely this angle and this angle, there is a relation, right? What is the relation? The relation is that this angle is half of this angle. So can I say, since O is the center, O is the center of the circle, angle AOC is double, right? 2 times angle ABC. This is because of inscribed angle theorem we have already studied. The reason is what? Inscribed angle theorem. So what is AOC? AOC is already 72 degrees. So can I say 72 degrees is equal to 2 times angle ABC. If I shift 2 to the denominator, can I say angle ABC is equal to 72 divided by 2, and 72 divided by 2 is 36. So can I say angle ABC is equal to 36 degrees. Correct? So we got one of the answers, that is the measure of angle ABC is 36 degrees. Now I need to find out angle BAD. But understand, what if I join BO? What if I join OD? What if I join OD? It is already given that AC is equal to BD. Understand, there is a circle. There are two chords AC and BD. Both of them are equal. It is already given AC is equal to BD. If you read the question carefully, AC is equal to BD is given. And we know that equal chords subtend equal angles at the center. Equal chords subtend equal angles at center, right? So tell me one thing, if angle AOC is 72, how much will be angle BOD? So here can I say angle BOD will be equal to AOC, therefore angle AOC is equal to angle BOD is equal to 72 degrees, right? Now again, using inscribed angle theorem, if I have a circle and if I have this angle, central angle as 72, how much will be this angle at the circle? At the circle, if BOD is 72, how much will be BAD? Can I say this BAD will be half of 72, that is 36 degrees. So we can say that by inscribed angle theorem, angle BAD is equal to half of angle BOD, that is half of 72, that is 36 degrees. I hope this part is clear to all of you. So we got the measure of this particular angle as 36 degrees. Now understand the triangle here. Now this is 36 degrees. We have ADB. Already given that AB is the diameter. So if AB is the diameter, how much will be angle D? Can I say angle D will be 90 degrees? It is given that AB is diameter, therefore angle ADB is equal to 90 degrees. Correct? Now if I take triangle BAD, So can I say in triangle BAD, can I say angle BAD plus angle ADB plus angle ABD, right, is equal to 180 degrees. What is the reason for this, by the way? You have to write down the complete reason. The reason for this is angle inscribed in a semicircle is a right angle. Now BAD is how much? 36. ADB is how much? 90 plus ABD is equal to 180. So 90 plus 36 is how much? 126. So can I say 126 plus ABD is equal to 180. So if I shift 126 to the other side, can I say angle ABD is equal to 180 minus 126, that is 54 degrees. Correct? So 54 degrees is the final answer. So I hope you have understood this question. ABC, we already calculated 36. BAD, we calculated 36. ABD, we have just calculated, that is 54. That is this part. This is 54, this is 36, this is 90. Correct? Okay, so let's have a look at a new question now. It says, in the given figure, AB is 9 centimeter, PA is 7.5 centimeter, this is given, and PC is 5 centimeter given. So chords AD and BC intersect at point P. Chords, there are two chords AD and BC, they intersect at point P. So this is the point of intersection and all the other values are given. We are supposed to prove that triangle PAB is similar to triangle PCD. This is very simple. Firstly, let us focus on proving the two triangles similar. That is triangle PAB similar to triangle PCD. So tell me one thing, if I take the two triangles, so in triangle PAB and triangle PCD, can I say angle APB is congruent to angle CPD because they are vertically opposite angles? Vertically correct? See this angle and this angle, vertically opposite angles, right? They're always equal. Now can I say, see there is an intercepted arc here. So can I say this arc is subtending angle A and the same arc is subtending angle C. So both of them are going to be equal, that is angle BAP and angle DCP, right? Angles subtended by same arc on the circle are equal. So I am not writing down the entire reason, I repeat again, angles subtended by the same arc on the circle are equal. So angle BAP is equal to angle DCP. Basically A and C are equal, A and C. So as I told you the reason, angles subtended by the same arc on the circle are equal. So two angles are equal or congruent. You can write down equal, you can also write down congruent, doesn't matter. So the two angles are congruent. So now can I say that the two triangles, that is triangle APB or PAB is similar to triangle PCD by AA test. AA test, but please write down AA test of similarity, not congruency. So they are similar by AA test of similarity. So the first part is done, easy. The two triangles are similar proved. Now let us focus on finding the length of CD. Now tell me one thing, already the two triangles are similar, right? Triangle PAB is similar to triangle PCD. So can I say the ratio of their corresponding sides are equal? So can I say PA by PC is equal to AB by CD is equal to PB by PD. All three are equal, correct? Put the values. PA is 9, AB is 9, PA is 7.5. AB is 9, PA is 7.5. So I get 7.5 is equal to, here is 9 upon PC. PC is 5, okay, write down 5 here. And we are supposed to find out CD. So what I can do is, I can just ignore this part and just focus on this. So what will be CD? So can I say CD will be equal to, CD goes here, 9 into 5 divided by 7.5. So you can multiply by 10 in the numerator and denominator. So you get 9 into 5 into 10 by 75. So 5 ones are 5, 15s are, correct? So 3 3s are 9, 3 5s are, 5 1s are, 5 2s are, and 2 into 3 is 6. So we can say that the length of CD is 6. Easy. The length of CD is how much? 6 units, you can say. So we have found out the second part as well. This is 6. Now let's focus on the third part. What is the third part? The third part is to find out the area of triangle PAB and area of triangle PCD, their ratio. Now tell me one thing, if I take the area of triangle PAB by area of triangle PCD, can I say the ratio of areas of two similar triangles is equal to the ratio of the squares of their corresponding sides, that is PA square by PC square. I can take PA square by PC square, or if you don't want to take PA square by PC square, you can also take AB square by CD square. See, AB and CD. You can see the last two letters are AB and CD, right? So I can take AB square by CD square. AB is how much? AB is 9. CD is how much? CD, if you recall, is 6. So I'll have 9 square by 6 square. So 9 square is how much? 9 square is 81. How much is 6 square? 6 square is 36. Both of them are divisible by 9, correct? 9 9s are 81, 9 4s are 36. So the answer is 9 by 4. You can also take the ratio of the other two sides, that is 7.5 square by 5 square, correct? So this is as good as 7.5 into 7.5 by 5 into 5, right? Because the ratio of areas of two similar triangles is equal to ratio of the square of their corresponding sides. So this is what you can take, that is 5 ones are, this is 1.5, 5 ones are, this is 1.5, 1.5 into 1.5 is 2.25. Now you might feel that both of them are different, but no, they are not different, because if you divide 9 by 4, see, if you divide 9 by 4, 4 2s are 8, you get 1, this is dot 0, 4 2s are 8, and then 205. So anyways it is 2.25, but because they have asked you the ratio, it's better to keep it like this, or else again you need to write down 225 divided by 10 and then you keep on cancelling that. So it's better you write it like this. Perfect. Let's continue further. Now let's have a look at one more question. the circumcenter of the triangle. What is the circumcenter of a triangle? It is equidistant from the three sides of the triangle, at equal distance from the three vertices of the triangle, the point of intersection of three medians, or the point of intersection of three altitudes. That is the question. Now they are talking about the circumcenter of the triangle. Now let's try to understand the meaning of circumcenter. Circumcenter of the triangle is nothing but it is the perpendicular bisectors and the point of intersection of it. So three perpendicular bisectors like this. So if I draw perpendicular bisector, I am saying that means this is 90 degree also, and these are two equal parts. So when I get something like this, and here is the center, right? So this is what? This is equidistant from all the three vertices basically. It is at equal distance from all the three vertices. Why? Because once you draw the circle, it goes something like this. This is a random figure. So it is equidistant from all the three vertices. So check. At equal distance from the three sides? No. At equal distance from the three vertices or vertices of the triangle. Correct? So it is equidistant from all the three vertices of the triangle. So I hope you have understood this part. So that's it in circles. I hope you have understood the chapter, and I hope you have understood all the problems that we have solved today. We are going to continue our series. We are going to do all the chapters as well going forward. Thank you so much. See you next time. Thanks a lot. Until then, keep learning with top scholars.